So, good evening, guys. Welcome back to the new lecture, which is will be continuing with the measures of dispersion. That is, which means statistics. So, in the last class, I hope my voice and all is clear, guys. Correct? Yes. Okay. Good. So, in the last class, what we did was we basically covered uh, the 10th standard revision part, that is measures of central tendency, which is mean, median, and mode. Now, as we discussed also last time, that when a data is given, it is not enough to only calculate the measures of central tendency, that is mean, median, and mode. So that's why it is not enough to just know what the data is doing at the center, which is measured by measures of central tendency. We also we also saw an example of Virat Kohli and Suresh Raina, who was more consistent since their mean value were same. So what gives us more information about the data is measures of dispersion. So measures of dispersion we saw also but we only saw for ungrouped data. So today we'll be covering measures of dispersion for grouped data. Correct? What are the measures of dispersion, guys? It is measures of dispersion are median, standard deviation, range. And in standard deviation, there are three types of standard deviation, right? Right? Mean, standard deviation, and so on. So we'll look at it now. Am I guys? Are you guys able to hear me? Audible or screen is clear? Yes, Santosh. Everyone, give me a thumbs up. Okay. Okay. So let's get started. Sure. Mean deviation about mean for ungrouped data. Correct? So let's see how to get this mean deviation about mean. Now we know what is mean deviation. How to calculate mean deviation? We first get the mean. After getting the mean, we subtract the mean from all the values of the observations, right? To get the deviation. Now, let's see what we have next. Correct, guys? So in the next part, we have this is the formula which we saw in the last lecture. Correct? Where x bar is the sum of all observations upon number of observations. I know we have done this in yesterday's class also, I think, but it's fine. We'll revise it. Where x is mean and n is number of observations. So we saw this example. Let's see the example. This is a given data. So first we need to calculate mean, right? What is the mean? Mean is x bar sum of all observations upon total number of observations, which is 10. Excuse me, guys. I am not calculating in front live because it's statistics, right? So we have to add all that, and that will just waste time. So I've already prepared the solutions as well, so you can go through it. Chalo, mean comes to 50. I think we saw this example yesterday, right? The sum of absolute values of deviation. The sum of absolute values of deviations. What does this mean? This xi minus x bar. So if we try to calculate it, see what it gets. This we get. Now, this finally comes to the value 84. What are we doing, guys? See, from every value, let me highlight it here. Yeah. From every value, we are subtracting the mean, you see, and taking the modulus value and then adding it. We'll see here, every value we are subtracting the mean. Everywhere we are subtracting 50. Correct, guys? So what do we get? We get 84, but this is not our answer. Mean deviation, we have to divide this 84 by number of observations, which is 10. So if we divide 84 by 10, what will get? 8.4. So that is our answer, right? This is the formula. So yeah, n means total number of observations. So which is 1 by 84, which comes to 8.4. 1 by 10 into 84, which comes to 8.4. Correct, guys? Let's move on to the next. Mean division about median for ungrouped data. What was the last topic? If you remember, the last topic was mean deviation about mean. Now we are studying mean deviation about median, right? So here the mean formula remains the same, just in place of x bar, which was mean. Here we have to consider capital M, which is median, right? We have to consider capital N, which is median. Just a second, guys. Yeah. Who all are there? Okay, today many of them are present. Superb, guys. Chal. Yeah. So first, how to calculate median? For median, we first get the data in the ascending order. So let's see an example first, and then we'll see. M is median. At first, we write the given data in ascending order, right? If the data or the number of observations are even, then we have two means, two medians, and if the number of observations is odd, then we have one median. Correct? So yeah, median is equals to n into n by 2 plus 1 if even, and if odd, then n plus 1 by 2. So here is the question. So first, let us try to arrange in ascending order. Correct? I think we'll try some example yourself. So I want you all guys to get a pen and paper and get me the median of this. Come on, let's see. Come on, get your pen, paper, or anything, pen and book, and write the given data in ascending order and get me the median. Chalo. You can write it in the chat box or you can unmute and say. Okay? Come on, guys. There are many students present. Santosh. Then we have JNV Medak. Okay. Chalo. Let's see who gets the answer. Did you get it? Come on, guys. I want answer. Write in the chat box or you can unmute yourself and say. Chalo. First, we'll get 10, right? Then we'll get 11 two times is there. In ascending order, so here is the ascending order. Now, if you see, the number of terms are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the middle term will be the median. Here, the middle term is 13, right? So 13 is our median. Now we just have to get the deviations. How to get the deviations? We subtract all of them from median. So median is 30. So what is the absolute values? We subtract all of them from 30. So if we try to subtract all of them from 13, we'll get this answer, which on addition will reduce to 27. Once it is reduced to 27, we will now find the final answer, that is mean deviation about median. We just have to divide 27 by number of observations, which is 11. So 27 by 11 is 2.45. Correct. I hope it is clear. Very simple, guys. Only calculative stuff is there. So it just test you कि हाँ कितना calculation fast है तुम लोग. Right? Please don't miss out that this weekend. I am telling you from now only. This weekend we'll be doing previous year questions on statistics, right? From JE. So don't forget to attend that lecture. Come on, let's see what we have next. Mean deviation about mean for grouped data. For till now we were doing ungrouped data. Now this is the grouped data. Correct? So as we all know, yesterday I have given you a table that group data can be grouped in two ways. Correct? What are those two ways? We'll revise it once again. Discrete frequency distribution and continuous frequency distribution. Discrete may we have single values of the data. But in continuous, we have a range, we have groups of values. Jैसे 11 to 20, 21 to 30, 31 to 40, and so on. I hope it is clear. Right, guys? Just a second. Yeah. Next, we have continuous frequency. Chalo. Discrete frequency distribution. Hello, guys. Hello. Is my voice clear? Hello. Hello. Yeah. All right. Let's continue. So here, the given data is, just a second, I'm checking. Yeah. Okay. So yeah, the given data consists of, correct. So what we have next is these values are occurring multiple times. That means x1 is occurring f1 times. Don't read this like a robot. Please listen first and then you can try to read it. Okay, so x1 is occurring f1 times, x2 is occurring f2 times, x3 is occurring f3 times, and so on. So one observation is occurring multiple times. Correct? So if we tabulate this, then we will get something like this. x1 fi. xi fi is a general way to tabulate it. x1 f1, x2 f2, x3 f3, and xn xn fn. Correct, guys? So let's see what we have next. Mean deviation about mean. How to find mean deviation about mean? First, we need to find the mean. Now, we already discussed in the previous class how to find mean for grouped data. Correct? So, how to find mean? It is summation fi into xi upon summation fi. So, first, let's see the theoretical part and then we'll apply it in the numericals. Correct, guys? Chalo. X bar, as I said, summation fi xi upon summation fi. Correct? So summation fi xi is equal to sum of product of all the observations of xi with respective frequencies of fi. So if we make a table, then we'll be easily get the sum of their products. Correct? So best way is to make a table. If you know, if you have used Excel, obviously you must have used Excel in your school, but Excel is basically very helpful in calculating or in calculation of the statistics. That means of all this data. So in mainly major companies, or as you can say major institutes also, they use Excel. Like almost every 100% of the companies use Excel for their data because it's very helpful, right? You must know Excel. You must have also used Excel, right? So let's see, n is summation fi, which is the total number of observations. Chalo. Now continuous frequency distribution. Let's see what we have in continuous frequency distribution. In continuous frequency distribution, the data is in groups, right? So let's see how to calculate the mean deviation about mean, right? So let me tell you, here we have examples. See, okay. First, before example, let me explain it to you in theory. Don't try to read it again. I am saying it's just theoretical part. First, listen to me what I'm saying. See, when we have groups, right? For example, let's say I have groups, which I'll write it here also. Just a second, so you will be clear in understanding. 30, 31 to 40, and so on. Correct? But if we want to find the mean, how to find mean? It is summation fi xi upon summation fi. The formula is same. We have to select the midpoint of this class. Every class ka midpoint we want, because in every class there is a range of values. We don't have a particular value. So while calculating mean, we need the midpoint of these values. So that's what is written here. So let's see how the table will look like now. The table is like this: class interval, frequency. Class interval means 11 to 20, 20 to 30, all the intervals. And frequency means how many of them have occurred in that interval. Next, we have midpoint, which I just explained. Midpoint of the class interval. Correct? Midpoint of the class interval. I hope I am making sense. Fi xi. Why? Because we want summation fi xi. That's why we have to calculate fi xi. Correct? Next, deviation. Deviation means we have to subtract the mean from all the values of xi. And lastly, we have to multiply them with fi. So here we'll get frequency. That means summation of all fi. All the data here, when we'll add it, what we'll get, guys? We'll get summation fi. Correct? Here summation fi xi. So if we divide this with this, we'll get the mean, right? So basically we must know how to make a table. That's it, guys. Very simple. So let's see mean deviation about mean. The formula remains the same. Summation fi into this. Just here fi came. Why fi came? Because that particular data is occurring multiple times. For example, if we see the record of 100 matches for Virat Kohli, okay, and if we divide the score from 0 to 100 in the groups of 20, such as 0 to 20, 20 to 40, 40 to 60, and so on. So we'll have multiple number of times or multiple number of matches where Virat Kohli have scored runs between 40 to 60. So that's why when there are multiple number of things occurring for the same from this for the same class interval, we have to multiply it with fi. Correct? Now, the shortcut method. I hope you know this. You have heard this. Shortcut method is basically, you have heard assumed mean method, right? From 10th standard it is. There are three methods to calculate mean. First is direct. Second is the assumed mean method, which is the shortcut method. Third is the step deviation method. So we'll discuss it one by one. Okay, yeah. Sorry guys, I was, as you know, I'm having cold and coughs, that why. Chalo. So, in this method, the shortcut method, or as you can see here, the assumed mean method. What we do, guys, is just we basically at the start of the question only we assume the mean. मतलब मीन को क्या करना है? Assume कर लो. भले ही we have to find the mean. Ultimately, we have to find the mean, but we first only assume the mean, right? So we'll assume the mean. How to assume the mean? We'll see the middle value, right? Average value. Okay. So after performing the assume mean method, we'll see how to perform. We can calculate the final mean by this formula, which is A plus summation Fi di upon n into C. A is the assumed mean, which we assumed at the start of the question. N is same, which is number of observation or frequency. Excuse me. C is the class interval. That means if a class is from 11 to 20, so what is the difference in the upper value and lower value? 9. 20 minus 11. Correct? So let's see class interval. Here we just need to add one column which is of the assumed mean. Correct? So frequency, this will be the given data in the question, that is class interval and frequency. Midpoint, we'll find out midpoint of each class interval. We'll calculate di. Now what is di? Di is xi minus a upon c. This one step extra we have to do. What is a, guys? A is the assumed mean. A is the assumed mean. Correct? So we'll get di. C is the width of the class. If the width of the class is from 10 to 20, the width is 20 minus 10, which is 10. Then same thing, fi di, xi minus x bar, f of xi minus x bar. All the other things remains the same. Just one thing we have to calculate is this, di. Correct? Let's see. Frequency mein mean deviation about mean. We'll get the deviation, but guess what, guys? This mean deviation, which you can see on the screen, the formula is not the correct one. Why? This formula is based on the assumed mean that we assumed at the start of the question. Please hear me very carefully. So the final mean we'll get how? By the formula on the previous slide which you saw. Correct? Chalo. Shortcut method for calculating mean, and now we have variance and standard deviation. So mean, we already saw this formula. A is assumed mean plus summation Fi di upon n into C. Variance. See, this formula may look very complicated, but it's not. Please see the formula very carefully. It is C square upon n square into bracket summation Fi di square minus summation Fi di the whole square. Here it is Fi into di square. Here it is Fi di the whole square. Correct. Standard deviation is very simple. Just take square root of variance, that is standard deviation. Correct? Chalo. Let's try to form the table. Class interval frequency, which is the given question, midpoint, di square, fi di square. This table, why are we using this table? Because to calculate variance. Because in variance, we require FIDI and FIDI square. FIDI and FIDI square. That's why we have two columns extra. One is DI square and one is FIDI square. Correct? Mean deviation about median. Till now, we saw mean deviation about mean for grouped data. Yeah. Mean deviation about median. Discrete and continuous. So first, we'll talk about discrete. Now, let me tell you one interesting thing about statistics. Someone left. Hello, guys. Am I audible? Okay. Everyone left? अचानक से. Hello, Santosh. You are from the which JNV, beta? Were they your classmates? Hello, Santosh and Raju. Hello, guys. Electricity problem. Yes, guys. Okay, you all also left. Hello, Santosh. Can you hear me? Hello, Santosh. Can you hear me, Santosh? Hello. Come on, guys. Give some response. It's already a theoretical chapter, and even if you will not respond to my calls, then how will we proceed with the lecture? Hello, Santosh. Santosh, you also left. No one's in the meeting. We'll wait 2 minutes, or will else we'll continue. Okay, so knowing the lecture, we'll continue. Chalo. So at first, we find the median of the given data. Obviously, guys, to find the mean deviation about median, you first require to find median of the grouped data of discrete frequency. So let's see. So obviously, guys, first we have to arrange the observations in the ascending order. After that, we have to get cumulative frequency. I hope you know what is cumulative frequency. Let's take an example. Right. So we have suppose a frequency. I am taking only frequency. We have the frequency 2, 7, 1, 8, 3. How to calculate cumulative frequency? The first term will remain as it is. Second term will be the addition of first two. Sorry. Second term will be the addition of the first two terms, which is 9. The third term will be the addition of the first three terms, which is 10. After that, you add 8. What will get 18? After that, you add 3. What will get 21? Correct? So, this data obtained is of cumulative frequency. After getting cumulative frequency, what to do? We want the central value. Right, guys? So then we identify the observation whose cumulative frequency is equal or just greater than n by 2. So first, here let's take an example. What is n? It's 21. No need to calculate n separately. N is basically sum of all this. It's 21. Right? Now we do 21 by 2, which comes to 10.5. Now, which cumulative frequency, let me change the color, is nearest to 10.5? Obviously, guys, it is 10. So, what class interval corresponds to 10? That will be my median. That will be my median. Correct? Chalo. This value of observation is the median. Correct? Now, after getting median, we can find the mean deviation. The process remains the same. The table also remains the same. The formula also remains the same. What is changed is, guys, just in place of mean, we now will have median. So as you can see here, in place of mean, now we have the median, which is capital M. We can get the following table. Let's say we'll have xi, we'll have fi. Now here is the most important part, cumulative frequency. Why cumulative frequency? Because we want median. So it is better to get cumulative frequency. After that same getting cumulative frequency, we'll get the median. After getting median, we have to calculate, we have to subtract the median from all the observations. And lastly, we'll have to multiply with f. Why? Because that observation is occurring f number of times. So median will be n by 2th observation, right? N by 2th observation. We have seen median in cases of odd and even. Discrete frequency distribution. Here it should be continuous frequency distribution. Sorry, guys. My mistake. I just forgot. Yes. Sure. Same thing, guys. Even for continuous frequency distribution, we have to order the data in ascending or descending. Correct? So, same way, because we have to find median. Then, how do we get the median class? We get the median class by n upon 2. As we just now saw, right? Cumulative frequency, we have to divide n by 2, and the closest to n by 2, we have to take it as median. N is the sum of all frequencies. Median ka formula is this. See, the median formula looks very tedious to remember, but there is no option. We'll have to remember it. Correct, guys? Chalo, let's see what are these letters. F, you must have guessed, is the frequency. C is the class width, which we already discussed. What is N and M? All these things. N is the sum of all frequencies, M and L. L is the lower limit of the median class. What is median class? We just now saw. When we get the cumulative frequency, after that, we divide n by 2 and get the closest value of cumulative frequency. The class interval corresponding to that closest value is called the median class. Now, suppose let's say the median class is 20 to 30. So 20 is the lower limit, 30 is the upper limit. We all know that. So L is the lower limit of the median class. F is the frequency. M is a cumulative frequency of the class just preceding. Preceding means above the median class. Correct, guys? So we just need to know L and M. What was L? Lower limit of the median class. What is M? Cumulative frequency of the class preceding means before the median class. C is the width of class interval. So we'll get class interval, we'll get frequency. These two will be given in the question itself. Next we have to find is cumulative frequency. Then here also we have to find midpoint. If you remember, for the product XI-FI, we don't have a particular value, as here we have class interval. So we need to find a midpoint of class interval. Then same thing, Xi minus median value, and lastly frequency multiplied by Xi minus median value. So we'll get this formula. Correct? I hope it is clear. Let's look at MCQs now. The formula for mean deviation about mean for ungrouped data. Come on, guys. Without even seeing options, I want you all to quickly remember the formula. What? I hope you remembered it. Let's see the options, then you might be sure. Chalo. We take, basically, we have to find mean. So for finding mean, we have to get sum of all observations. What is the meaning of sum? Sum is summation upon total number of observations. If you look carefully, option 4 is of no use. because it has plus here. Option 3 में we don't have mod. Modulus is necessary, guys. Please try to recall. Modulus is very necessary. So our answer is 2. Chalo. The formula for mean deviation about median for grouped data. Now please remember, guys, there are two types of data, correct? Grouped and ungrouped. For ungrouped data, in the formula, the only difference is we just do not multiply by f, which is frequency. Why? Because in ungrouped data, we don't have frequency, we just have random numbers. But if we want, we can convert the ungrouped frequency distribution data into grouped frequency distribution data. Let's take, for example, sorry, we'll look at this MCQ once I clear out your concepts. Suppose I have been given the ungrouped data or random data as 3, 4, 3, 8, 10, anything, guys. 11, 8, 3, 7, 7, 2, 10, 3, 4, 8, 7, 2, and so on. Now, here, sorry. There are multiple numbers which are repeating. For example, let's say 3. Now, for 3, 3 is repeating 4 times, right? That means this ungrouped data will be better if we convert it into grouped data. Now, in group data, you can either form the class interval or you can directly get without forming class interval. I'll show you both. Okay. So here, if I try to group this without forming class interval, here I'll get xi and here I'll get fi. Xi may will take all those numbers which have uniquely appeared here in ascending order. So first is 3, second is 4. No, guys, sorry. First is 2. Right? 2 is also there. So 2, 3, 4, 7, 8, 10, and 11. How many times have 2 appeared? 1, 2. So 2 times. I'm crossing the data so we can verify that we have covered all the numbers. 3 कितनी बार आया? 1, 2, 3, 4. 4 times. 4, 1, 2. 2 times. 7, 1, 2, 3. 8. Again 1, 2, 3. 8 is 3. Yeah, sorry. What is 10? 10 is once, twice, and 11 is once. So this we have converted into group frequency distribution. Obviously, guys, if we look at it, the group frequency distribution looks better than the ungrouped one. It's more systematic, correct? So it's better if we have many frequencies or many times one of the observation is appearing many times. It is better to convert it to group and then solve. Correct? The difference in the formula, guys, is only in F. Frequency नहीं आता है बस in ungrouped. So let's see this. The options. Come on. I gave you the biggest hint. The grouped data, it's a grouped data. Means frequency should come. So answer is option number 4. Sorry. Answer is option number 4. Right? Because the frequency must come. Okay, guys, I think that's all. Time is also up. It's already time up. So thank you guys for attending this lecture. In the next lecture, we'll be seeing some questions and we'll be seeing how to calculate variance and standard deviations. Correct? And yeah, guys, that's it from my side. Bye bye, everyone. Take care.